Welcome to Brain Vision.
Okay, so this problem asks us to determine the internal forces at point J when alpha equals 0. Alpha equals 0 means the 780 Newton force is acting exactly flat. There's a 5, 12, 13 triangle here based on the measurements that are given in the picture. We know that there's going to be a reaction force at B and Bx and By due to the pin that's there, and there will be a reaction force at A due to the string that is at A. And then later on, we'll use this free body diagram for just the section B to J. But for now, going off of this top diagram here, we'll take the net moments about A. And the net moments about A will be caused by that 780 Newton force, which is acting 0.72 meters away, plus By times 0.3 meters, at 0.3 right there. So that means By equals 1,872 newtons downwards, or negative 1872 newtons. And now the force in the y direction, we're going to use our force triangle. So A times 12 over 13 minus the 1872 we just found equals 0. And so A equals 2028 newtons. Now we'll go for the x direction. Force in the x direction equals the 2028 that we just found for A times 5 over 13 plus the 780 at the bottom plus Bx, and that will equal 0. So then I can solve for Bx, that's the only unknown, and you should get that Bx equals negative 1,560 newtons, or 1,560 newtons to the left. If we go back up and look at this free body diagram, we have the force at the bottom, this reaction B, and then the moment reaction. We know that Bx is 1,560 newtons, By is 1872 newtons. You can see that there's this little force triangle set up here, and this little force triangle set up here, which tells us that this small vertical piece right here is 600 newtons plus the vertical piece from By, or sorry, not vertical, it's parallel to the bar. It's 600 newtons from Bx, 1728 newtons from By. And then as far as the forces perpendicular to the bar, from By we have a 720 Newton contribution, and from Bx we have a 1440 Newton contribution. Again, that just comes from the setting up the 5, 12, 13 force triangles there, and then 5, 12, 13 force triangle there. So we run through the same process. Net force, now we're going parallel to the bar. It's going to be 1728 newtons plus 600 newtons minus F equals 0. So F equals 2,328 newtons. And then using the force triangle, I know that angle is 67.4 degrees. Next, we will do the net force in the perpendicular direction equals 0 equals 720 minus 1440 plus B equals 0. Therefore, B equals 720 newtons, and that will be in the direction of 22.6 degrees. Now I need to find the total length of b to j, which is going to be taken by using Pythagoras' theorem, 480 squared plus 200 squared and the square root of that. So we know that, if we do the quick math on that one, Vj equals 520 millimeters. And then we're going to take the moment about our point here to find out what exactly the moment is. Nothing caused by V and F, they're distances 0 away. So we're going to have moments that are basically caused by the 1560 Newton force and the 1872 Newton force. So if we do the math, at the moment about J is going to equal 1560 times 0.48, which is that vertical distance, or excuse me. Yes, sorry, 1560 times 0.48, which is that vertical distance, and minus 1872 times 0.2 minus m equals 0. So m equals 374 Newton meters. Clockwise, if you want to use there's an alternative approach. If you want to use this Vj equals 520 value, you say that the 1440 and the 720 are the ones that cause the moments, and so then the direction is just this way, which is the 0.52. But regardless, you should get the same answer of 374 Newton meters in the clockwise direction.